Download this code and get free GPT-4o from codegive.com, link in the description below. Sure. In this tutorial, we'll explore how to compute the distance between vectors using numpy, a powerful library for numerical computing in Python. What is distance between vectors? In mathematics, the distance between two vectors is a measure of how far apart they are in space. There are several ways to define this distance, but the most common are 1. Euclidean distance, the straight line distance between 2 points in Euclidean space. 2. Manhattan distance, the sum of the absolute differences of their Cartesian coordinates. 3. Cosine similarity, a measure of similarity between two non-zero vectors, defined by the cosine of the angle between them. Installation. First, ensure that you have numpy installed. You can install it using pip if you haven't done so already. Code example. Here's a step-by-step example of how to calculate these distances using numpy. Explanation of the code. 1. Defining vectors. We create two vectors vector_a and vector_b using numpy arrays. 2. Euclidean distance. We use np.linalg.norm, a, b, to compute the Euclidean distance. This function calculates the norm, or length, of the difference between the two vectors. 3. Manhattan distance. We use np.sum, np.abs, a, b, to compute the Manhattan distance, which involves calculating the absolute differences between corresponding elements and summing them up. 4. Cosine similarity. We compute the dot product of the two vectors using np.a, b. Then, we normalize both vectors by computing their norms and dividing the dot product by the product of these norms. 5. Display results. Finally, we print the calculated distances. Running the code. You can run this code in any Python environment where numpy is installed. You should see output similar to conclusion. In this tutorial, we covered how to compute various distances between vectors using numpy. These metrics are widely used in machine learning, data analysis, and more. Understanding how to manipulate vectors and calculate distances is fundamental for tasks such as clustering, classification, and similarity analysis in high-dimensional spaces.